Okay, in this video I'm going to show you how to use the Energy Plus section of the workflow to perform a thermal calculation with dynamic shading. First of all, I'm just going to show you the construction, because if you watched the shared assumptions video, you'll know that the input geometry is very simple for the Energy Plus section. So that's because it's defined down here. So for each, I'm just going to give you an example for the facade. For each layer of the facade, you use this component to create the material, and then you give it a name and a roughness and a thickness, and then you combine all of these materials to an Energy Plus construction component like this that you then give a name. You do that for your floors and ceilings and internal walls and external walls, and then you take all of these and you add them to this component up here, which will then, once run, add them to the Energy Plus library. Now I'm just going to show you the dynamic shading box down here. There's a slight hiccup when using BSDF files for dynamic shadings in Energy Plus right now. There's a bug that means that it's not working properly. So we're going to get around that by creating the shades using this component called Energy Plus Window Shade Generator. So first of all, I'm just going to connect this low E coded window to the window up here, to the window component in the geometry up here, and then we're going to create the external shades after using this component. The shading schedule is the binary schedule that we created in the shared assumptions video, and then you choose the shading control type. There's a lot of different types that you can choose. We're using Venetian blinds in this case, exterior Venetian blinds, and then you set your specifications in this. You can see here we have a 30-degree shading angle and horizontal, which is also the default value. Now I'm just gonna double-click these two toggles to run the simulation and create the window shades. I'm going to pause the recording while I do that. Now the component has run, and you can see here that we've created a lot of B-reps. Over here, a lot of surfaces, and we can just use this preview to take a look at it in the Rhino window. You can see here we have the window, that is this one that I've marked now, and then we've created all the shades with the 30-degree shading angle here. So that's what it looks like now. And then we're going to this component. The output honeybee object with shades is then connected to this honeybee zone data point. So this is the one with dynamic shades. Taken the honeybee zone up here, connected it to the honeybee object with shades component, and once that's run, we've created the honeybee zone with shading, and that's the one we use up here. So I'm going to connect this one to the component over here, which allows us to set the zone thresholds. I've just set ones for heating and cooling, but you can tailor it to your own project. Gonna take the honeybee zone's output and use it for the input in the next one, which allows us to set the occupancy schedule and a variety of other schedules for lighting and equipment and such. I've just created a schedule, an 8 to 5 schedule on weekdays, normal office hours, and connected that one up here. And then again, you take the honeybee zone's output for the honeybee zone's input, and this component allows us to set the zone loads. So you have the equipment load and the infiltration and the amount of people giving off heat and that sort of thing. You can specify that using this component. So we take that and connect it to the run energy simulation component up here. That one also has the energy simulation parameters, which are set up here. And there's this component called additional strings, which when we're using dynamic shading needs to be connected to this panel. So I'm going to connect that one here. And now we're ready to run the simulation. I'm going to double click this toggle and this toggle to write and run the simulation. And I'm going to pause the recording while I do that because it may take a while. Okay, now the analysis is done running. We can use this component over here to see a list of the outputs that we've calculated. You can get heating and cooling and solar gain and a bunch of other things I'm going to show you an example using the operative temperature to find out if there's any overheating in this office. That needs to be done according to the EN 15251 standard, which specifies that we only look at the occupied hours. So I'm going to start by selecting all the occupied hours using this occupancy schedule from week component and selecting only the occupied hours. So that's the only list that's going to be, the only ones that are going to be selected using this component. And then from those values, we can then specify if we want to know how many hours are above the temperature we specify using the slider. As you can see, there's 894 hours above 25 and 410 hours above 26 degrees. According to the EN 15251 standard, you can only have about 100 hours above 26 degrees in a year, so we are way above that in this situation. So something will need to be amended, but you can look at that when you do the project yourself. So that was a quick run through of how you do a dynamic simulation using Energy Plus in the workflow.